In this video, we're going to talk about piecewise functions. This is for section 3.2, the second part. And actually, piecewise functions were first mentioned in the book in 3.1, but I thought we would just do one whole video on piecewise functions. So far we've looked at equations of functions, just one equation, and if you wanted it to look like something, you'd have to know how to write an equation for that shape. But we have a lot more flexibility than that. We can combine all kinds of, anything we know how to do, we can combine them all in a graph. So that's why it's called piecewise. In this one, f of x that's here, we actually have three pieces to this function. The key is that it's still only one answer. So no matter what x I plug in, I can only get out one answer. I'm not going to take a number and plug it into all three. Because if you see over here on the right, it has these constraints on x, right? So I'm only going to use the first one if x is less than or equal to -1. Okay, so any number that I pick, if it's less than or equal to -1, I'm going to plug it into the x plus 1. So you can really look at these as separate. You can say, well, f of x equals x plus 1, but I'm only going to do that if x is less than -1. So for f of -10, I would get -9. For f of -3, I would get -2. For f of -1, because it could be equal to it, right, I get 0. Okay? But what if x isn't less than -1? Right? What if x is 0? Well, then it doesn't fit that one anymore. So it has to fit. See, we have to see where it's going to fit. So 0 would be in this one, right? Because x is between -1 and 2. So if x is 0, we don't plug it into the first one. We plug it into the second one, because that's where it fits. So that would be 0 squared minus 2, so that would be -2. If f is -1/2, that would fit in between -1 and 2. So I would plug it into the second equation. So -1/2 squared would be +1/4 minus 2, so that would be -1 3/4. Okay? What if f is actually 2? Well, because this is an equal, 2 goes into the second equation. So I would go ahead and plug in 2 there, and it would be 4 minus 2, so the answer would be 2. But if I get any bigger than 2, so if I want to do f of 3, well, now it fits in the third little constraint, right? This is saying if x is bigger than 2, then I plug it into this equation. And that equation is f of x equals 2. The answer is always 2, right? So if I have f of 4, that would be 2. If I have f of 5, that would be 2. And so on. Okay, so that's how we evaluate a piecewise function. You have to look at what those constraints are. And the constraints are always on x. We're deciding, before we ever plug anything in, we have to figure out which equation we're supposed to use. Okay, so we also want to graph these piecewise functions. And any one of these we could graph, but we want to combine them all onto this graph. Okay, so if we look at that first equation, f of x equals x plus 1, that's a line, right? So that's a line that has a slope of 1 and it goes through 1. But remember, I only want to use that line when x is less than or equal to -1. So that would only be this part, right? So that's the only part I want to use. Okay, I'll get rid of the rest of it. And you notice that we always are going by x. So here x is, I'll use my vertical line to talk about x, right? So here x is -6 and -5, -4, and all the answers for all these numbers less than -1 are that line. Okay, and I left a point on the end here to show that at -1 it's still that. Okay, so that would be my first part of my graph. And when I graph them, I'm always going to do it in pieces, in the very pieces that are defined. So the next part of my graph would be between -1 and 2, right? So I'm looking for the part of the graph that goes from -1 to 2, this little section right in here. And you might recognize this, that this is a parabola. Okay, so I could graph that parabola, and here I have it graphed as a dotted line, but remember, I don't want to use the whole thing. I only want to use between -1 and 2. Okay, so that's the only part that I want to use. I can get rid of the rest. And you notice that right here at -1, I'm including the endpoint on this ray, this line here from the original line, from the first piece. I don't include a point on that piece of the parabola because right here is a less than but not equal to at -1. And we can't make it equal to. We don't want it to be equal to because then it wouldn't be a function. I would have two answers for -1. So you can't include it on both ends. Alright, so that's the middle piece. Now the third piece, this f of x equals 2, that's just a horizontal line. And it starts when x is greater than 2. Right, so that's just a horizontal line at 2. And it just so happened that when if we plugged 2 into the second equation, and if we plug 2 into the third equation, we actually get the same answer. So these two lines meet up, which is kind of nice when that happens. So that is my graph. Kind of funky, right? It can be any weird shape. These functions, these pieces of our function can be anything. Anything we know how to graph, we can put it into here. So here's the quiz question for 3.2b. Find f of -2 for this piecewise function. So write this down and enter the answer into the quiz on Canvas.